Okay, so Nathan, this is the question that you have asked me to have a look at. Now, this question has nothing to do with graphs of functions. Uh, Although we are talking about functions here, it is not the particular topic you are at. This is actually differentiation and integration, which is something that you will have to do on the later stage. Okay, but it's still part one of the of your two themes in terms of AS level. So there is going to be work that you need to revise. So you probably have to do a differentiation in order to understand differentiation, and also you have to do integration, because integration is the opposite operation of differentiation. So it's always often referred to as antiderivative, because what you are given here, when we just look at the question, let's look at the question first. So they say to you, a curve with the equation f of x. So we don't know what the equation of the curve is, and in order for you to find the equation of the curve, you have to do a few more things there. So it says it passes through the points 0, 2 and 3, -1, and it is given that the derivative of that function is kx squared minus 2x, where x, or the k rather, is a constant, and you need to find the value of that k. So in hindsight, what you know is, you know that f of x refers to a particular function. We are not given a function, but we are given the gradient function. We are given the gradient function, which is kx squared minus 2x. So we need to find the antiderivative of that. We need to integrate in order for us to find what that function is. But then there is a little bit of a catch there, because when you find the antiderivative, or when you integrate the function or the gradient, you are going to have an arbitrary value of c, because you don't know where that graph passes the value or the y-axis. So there's going to be a few things there that you are going to be using, because you are given 2 points already to consider. So once we are given these points, we can actually substitute once we get the gradient function. So I already showed you how this is done, but under here I have got the basic rules now. So say, for example, you are asked to integrate, okay, something like x squared. Now, in order for you to integrate this, so I'm going to say you're going to integrate x squared with respect to x. And the way you do that is you are adding 1 to that power, like what I've indicated here. So in this particular case, you're going to have x cubed, and then you are going to divide by that same number that you have there. So in this case, you are going to divide by 3. All right, and then obviously, since again you have to say plus c, because you don't know where the graph or the curve will cut the y-axis, right? So this is the integration of this particular we are supposed to integrate that. Okay, so now we have the gradient function here, so we are going to integrate. We're going to use the same concept, and there is something called the sum and difference rule when you are going through your notes and when you're starting to understand the concepts of integration. So what we're going to do, and in order for me to find f of x, I will say that I'm going to integrate the gradient function given to me, kx squared minus 2x with respect to x. And the way we do that, I'm just going to write this as y, because I'm looking for the function. So we're going to add 1 there. So the k is just a constant. So if we add 1, we're going to get x cubed upon 3, and then you have minus 2x. Now if you're going to add 1 here, you're going to get a 2 divided by 2 and plus c, which is the constant of integration. So this cleans up to, well, I can have this as x cubed over 3, and maybe I can put my k there, minus x squared plus c. Right, so that is the gradient function now, or that is the curve, but we don't know what the value of c is. So in order for us to find the value of c, we are going to substitute for x and y into this particular function. So that means everywhere with an x, I'm going to replace it with 0. So that means I'm going to have y because that's x and that's y. Y is 2, x is 0 times k minus 0 squared plus c. Well, this is going to give you c equals to 2, okay? Because those zeros just cancel out there. Now, my equation is now y equals to x cubed over 3 times k minus x squared plus 2, which is my constant of integration. So I'm now given new points, which I'm going to substitute in there. So y is negative 1, remember it's xy, equals to 3 cubed over 3 times k minus 3 squared plus 2. Well, this is 27 divided by 3, that's 9k. And this is going to be minus 9 plus 2. All right, so this is actually now cleaning up nicely to minus 9 plus 2. And minus 9 plus 2 is nothing but minus 7. And if you take this minus 7 over, okay, negative 1 plus 7 equals to 9k. 7 minus 1, that is 6, equals to 9k. So that means k will be 6 divided by 9, and it simplifies nicely to 2/3. And that is the value of k. So again, once you do get to do integration and differentiation first, then you'll grasp more what this is all about. Okay, also I'm going to share this with you. From the 13th of June till the 22nd of June, I am going to have a workshop with AS level learners, okay? AS level learners. And I'm going to do theme 1, which means I'm going to start with a little bit of ending on functions, just a little bit of work on functions, and then we're going to do the work on trig. We're going to do vectors. There's also circular trigonometry, okay? Circular trigonometry, vectors, and then I'm going to do differentiation as well as integration. So for those of you who are interested in joining these classes, since I'm putting this information up in YouTube, please do contact me and make arrangements, because if you are not from my school, there is a fee that you will have to pay. But make arrangements. But Nathan, of course, you are welcome to attend as always. Otherwise, I'll share the information and also keep you up so that you can be at least ready. So once you start with school on the 15th or the 18th of July, you are done with those topics, and now you can focus on theme 2, which is further integration, further differentiation, stuff like that. Okay, and of course I will have another workshop towards close to the end of the year where I do a 10-day workshop where I then do the rest of the topics.